Let's dive into the fascinating world of archiving within WinCC OA, a powerful SCADA system designed to monitor and control industrial processes. Archiving in WinCC OA is all about systematically storing and managing the data generated by these processes, ensuring that we can access and analyze this information whenever needed. In the presentation, we will discuss several key aspects of archiving within WinCC OA, focusing on the Next Generation Archiver, NGA. We will start with an introduction to archiving and its importance. Then we will explore NGA's features and the various license options available. We will compare different database backends like InfluxDB, PostgreSQL, and Microsoft SQL Server, and address the restrictions and additional information related to NGA. At the end of this chapter, we will explain the architecture of NGA, detailing how its components ensure efficient and secure data management. We will then wrap up the presentation by sharing some additional information on the topic of archiving with Oracle. First, let's talk about the key components involved in the archiving process in WinCC OA. Archiving in WinCC OA involves saving the original value, source time, and status bits of data point elements. At the heart of it all are tags. These tags represent the data points in the system that we monitor and control. They can be configured for both reading and writing operations, making them incredibly versatile. Next, we have the central configuration. This is crucial because it ensures that all the system settings and parameters are managed centrally. This centralization not only makes maintenance easier, but also ensures consistency across the entire system. In WinCC OA, the central configuration for archiving involves several methods to manage the storage of values and alerts. The primary methods used are History Database, or HDB. This is used to save value changes. The History Database is optimized for high-speed data retrieval and storage, making it ideal for storing time series data. RAMA. This is an alert database used to save alerts generated by the system, ensuring that historical alert data is available for analysis. Relational Database, or RDB. This can save both value changes and alerts. It is perfect for storing structured data in a relational format and allows for complex queries and detailed data analysis. One of the standout features of WinCC OA is the Next Generation Archiver, NGA. This modern, efficient archiving solution is designed to handle large volumes of data with high performance and reliability. The NGA can archive alarm data, ensuring that all critical events are recorded and can be reviewed later. It supports both reading from and writing to the archive, allowing for flexible data management. Let's have a closer look at archiving with NextGen Archiver. Archiving with NextGen Archiver, or NGA, elevates our archiving system to state-of-the-art technology. Now, let's discuss the benefits of NextGen Archiver in detail. The NGA combines the strengths of both the history database and the relational database, while introducing modern features like direct database access and modular backend options. The NGA offers increased performance for read and write operations compared to traditional value archives in HDB, Oracle RDB, and RAMA. It also provides seamless data buffering. The NGA has got to connect to a variety of modern databases, including InfluxDB, PostgreSQL, and Microsoft SQL Server, and is able to connect to any other database with a custom implemented backend API. This flexibility allows us to choose the best database for your specific needs. The NGA also supports multitasking by enabling a central database for multiple distributed systems and storing data in multiple databases simultaneously. This not only improves efficiency, but also helps save costs by decreasing the necessary hard disk space and offering a variety of open-source databases. Let's talk about features. The Next Generation Archiver, or NGA in WinCC OA, offers a comprehensive set of features designed to enhance data management and archiving capabilities. General features include a historical archive that supports reading and writing of events and alerts, availability for both Windows and Linux, automatic segmentation of data, which helps in keeping the data organized, automatic backup and storage management, support for data storage in multiple databases, either locally or remotely, a powerful SQLite query language with aggregation and statistical functions enables complex data analysis, while redundant and distributed architectures improve system reliability and performance. Additional features include event-driven storage that prevents data duplication, additional smoothing options to reduce the amount of stored data, support for all WinCC OA data types, including strings and arrays, the ability to add or correct values while retaining the original data, and storage of quality status along with a 32-bit user-definable status. Other features include various methods for data compression and statistical calculations. The NGA supports a wide range of built-in statistical functions for data compression, such as sum, minimum, maximum, and average values. The grouping by time periods, for example, group by 1 hour gets you an average value for every hour. Plan features include autonomous calculation of statistical values within the database. All data connections are secured using SSL. An import feature facilitates easy migration to NGA by allowing users to import historical values and alerts from existing databases, like HDB and RAMA, into the NGA framework without losing historical data. A backend API is available to facilitate communication between the NextGen Archiver NGA and various database backends such as InfluxDB, PostgreSQL, and Microsoft SQL Server. Database schemas are documented in our WinCC OA online documentation at winccoa.com/documentation. Next, we will have a look at the topic of license options. This slide provides a quick and rough overview of the licensing options for the NGA. The licensing options are tailored to different project sizes and requirements. The NGA Basic License is integrated with the WinCC OA Server Basic License and can be used in any project but includes several restrictions, such as limited archive groups. The NGA Standard License is suitable for projects with up to 150,000 power tags and includes the option to connect one freely selectable backend, which can be extended with additional backend connections. The NGA Premium License is designed for large projects with more than 150,000 power tags and allows the connection of multiple backends. The NGA backend connection enables the connection of another freely selectable local or remote backend for the next generation archiver. It is only available for standard and premium option. Please note that there are specific MLFB numbers available for all these options in version 3.20. This comparison outlines the key features and differences between the NGA Basic, Standard, and Premium licensing options, highlighting the availability of local databases, redundant system archiving, backend connections, project size limits, and archive group capacities to help you choose the best option for your needs. Local database. All licensing options, Basic, Standard, and Premium include a local database. Archiving in a redundant system. This feature is available across all licensing options. Backend connections. The Basic option does not include any backend connections. The Standard and Premium options each come with one freely usable backend connection. Additional backend connections can be purchased separately. Project size, power tags. The Basic and Premium options allow for unlimited project sizes, while the Standard option is limited to 150,000 power tags. Archive groups. The Basic option allows for a limited number of archive groups, up to 7, with 6 event groups and 1 alert group. The Standard and Premium options offer unlimited archive groups. In essence, the Premium option provides the most comprehensive features, including unlimited project size and archive groups, while the Basic option offers essential features with some limitations. The backend connection available with the Standard and Premium licenses, allowing for one freely usable backend connection with the option to purchase more. If you are using WinCC OA version 3.19 and higher and the BACnet driver, you may also need to upgrade your NGA licenses, depending on the usage of a local or remote database. Using a local database backend, no upgrade is needed, and it allows the use of any number of BACnet objects. There are no limitations on BACnet or power tags. Please note that power tags and BACnet objects are counted individually. The NGA Standard Option license is required if you use a remote backend and less than 30,000 BACnet objects. The NGA Premium Option license is required if you use a remote backend and more than 30,000 BACnet objects. Please note that the MLFB order numbers for WinCC OA 3.20 version are as follows. The license table we have discussed so far applies only to versions 3.18 and beyond. In version 3.17 of WinCC OA, the licensing for the Next Generation Archiver, NGA, is structured differently compared to later versions. Therefore, when upgrading from version 3.17 to a newer version, additional licenses may be necessary if your current license does not meet the requirements for the features or connections you intend to use in a newer version. Here is an example regarding the number of archive groups in different WinCC OA versions. Version 3.18, the NGA basic option introduced a limitation, which allowed only 5 event groups and 1 alarm group. In version 3.19, this limitation in the NGA basic option was extended to include 1 additional event group, allowing for a total of 6 event groups and 1 alarm group. If your 3.17 configuration requires more groups and exceeds these limits, it will be necessary to additionally license at least the NGA standard option to accommodate the additional groups. To illustrate the licensing requirements more clearly, consider the following examples. The requirement is the following. You want to use a local InfluxDB on the OA server, a remote InfluxDB for the production line, and a remote MS SQL DB for the whole plant. What license options do you need? The answer is at least the NGA standard option plus an additional backend connection license. Here is why. The local InfluxDB is included in the NGA basic version. But if any remote connection is needed, you will need to license at least the NGA standard option. In this example, this would be the InfluxDB for the production line. For an additional remote DB connection, other than the one already included in the standard package, an additional NGA backend connection license is necessary. In this example, this would be the remote MS SQL database for the whole plant. Next example. Here is the requirement. You just want to use a remote MS SQL backend. What license options do you need? The answer is the NGA standard option is sufficient. Here is why. If any remote connection is needed, you will need to license at least the NGA standard option. This option provides the necessary support for connecting to a remote MS SQL database without the need for additional backend connection licenses. Let's have a deeper look at the backends available in WinCC OA. WinCC OA supports various backend options for data storage and management, each with its own specialization and features. Let's compare InfluxDB, PostgreSQL, and Microsoft SQL Server. First up, InfluxDB. This is a time series database, which means it's optimized for storing time-based data. It's been available since WinCC OA version 3.17 and is open source. You can run it on both Windows and Linux platforms, and it supports operation in redundant systems, which is great for reliability. Next, we have PostgreSQL. This is a general-purpose relational database, so it's quite versatile. It became available with WinCC OA version 3.18 and, like InfluxDB, it's open source. It also runs on both Windows and Linux and supports redundant systems. Finally, there is Microsoft SQL Server, also a general-purpose relational database. It was introduced in WinCC OA version 3.18 patch 006. Unlike the other two, this one is a commercial product. It operates on Windows for both the database and client, but you can also use a Linux client. And yes, it supports redundant systems as well. So, in summary, all 3 databases support redundant systems and run on multiple platforms, but they differ in their specialization, licensing, and the specific versions of WinCC OA they were introduced in. The NGA backend API provides an environment for customers to build specific backends and is available for Windows and Linux. It includes a build framework, templates, and documentation, and supports all NGA options. This API provides the necessary interfaces and functionalities to create and integrate your custom database backends into the NGA framework. The implementation effort is approximately 500 hours for implementation and 500 hours for testing and high availability. The complexity and effort depend on requirements such as write-read operations, redundancy, performance optimizations, and database functionality. Our next topic we are going to cover is strategy. In the field of archiving, we currently navigate between two distinct worlds: legacy and state-of-the-art solutions. While the previous archiving solutions were and are still fine to use, they have their limits and are not future-proof for the long term. The existing archiving world and option range consists of the following technical solutions: Value Archives, History Database HDB for archived values, RIMA for alarms, configuration, and last value storage, and Oracle RDB. For HDB and RIMA, we give a guarantee for full support up to version 3.21, plus 7 years from now when under maintenance. These solutions, while robust and highly developed, face technical limitations that prevent their use beyond 2038. On the other hand, the state-of-the-art archiving option range consists of SQLite for configuration and last value storage, and the Next Generation Archiver, NGA, for alarms and values. While NGA could be chosen without SQLite, it is mandatory to use NGA if you want to use SQLite. Both archiving option ranges and all individual options are valid for new projects and are fully supported. For new projects, however, it is recommended to use SQLite and NGA with the PostgreSQL backend, which has become the new default starting with version 3.20. What is the outlook for Oracle? If you want to use Oracle as archiving backend, the RDB option is available. Please keep in mind that the end of life will be in 2038. Security updates will happen regularly, and Oracle version upgrades will be aligned with WinCC OA major versions. What about Oracle as NGA backend? Currently, there is no NGA Oracle backend planned, as the number of supported NGA backend types should be kept low. In general, we only expect very few new Oracle installations per year. Custom backends can be developed using the backend API anytime. Customers can continue to rely on and trust RDB for Oracle archiving. Future versions of WinCC OA will feature a migration path from Oracle RDB to NGA for any backend, preferably to PostgreSQL. Customers interested in an Oracle backend for NGA should contact ETM Product Management at pm@etm.at. What is the outlook for InfluxDB as NGA backend? InfluxDB 1.8 continues to be a valid backend option for NGA archiving. However, Influx decided to release the 2.x series with many incompatibilities, making it economically unfeasible to support. While the current version of InfluxDB 3.s is more compatible than version 2.x, we still expect significant effort to support it due to frequent changes Influx is making with version 3.x. Additionally, there is currently no open-source version available for 3.x. Finally, the enterprise variant costs about 50k euros annually, which exceeds most customer project budgets by far. In summary, due to the volatility and frequent changes in InfluxDB's offerings, we currently cannot recommend InfluxDB as a future-proof backend for WinCC OA NGA archiving. What's new in WinCC OA 3.20? Version 3.20 introduces several improvements to make archiving easier and more cost-effective. Here are the highlights. NGA PostgreSQL will be the new default option for WinCC OA, with an installation toolchain that simplifies integration and local setup. Remote PostgreSQL backend needs to be installed manually. Local InfluxDB backend can be automatically installed. MS SQL needs still be set up manually in any location. In the NGA basic package, the number of included event archive groups has been increased by 1, facilitating migration from value archives, HDB. Any type of local backend is now included in the NGA basic package, which was previously limited to InfluxDB only. NGA standard and premium packages are not limited in group numbers. Another highlight in 3.20 is the NGA importer. The new importer functionality in version 3.20 simplifies transitioning to NGA. Users can easily switch from RIMA to SQLite. This was possible manually in 3.19, but now it's automated in 3.20. From value archives to any NGA database option, and from one NGA database to another, for example from NGA InfluxDB to NGA PostgreSQL. The best part? No additional licenses are needed for the import. You can start importing during a project upgrade to 3.20 or manually at any time. The importer functionality itself has actually been available since version 3.19 patch 009. Newer values are imported first. The importer comes with an automated dynamic threshold. This means it only uses free system resources, avoiding the buildup of buffers. So, you can import data while ongoing archiving operations in a running production system. Your production system is still running smoothly. Looking ahead to version 3.21, several enhancements are planned. Here are the highlights: an increase in performance and a reduction in the footprint of PostgreSQL, faster trending and reporting with compression levels. Additionally, efforts will be made to close existing gaps and add missing features for NGA, restrictions when using NGA. The Next Generation Archiver, NGA, has several restrictions that users need to be aware of. The NGA, NextGen Archiver, cannot be combined with HDB, Historical Database, and/or RDB, Relational Database Management System. Also, SQLite, a successor of RAMA, can only be used with NGA projects. Parallel archiving is possible using 2 or more backends, such as InfluxDB and PostgreSQL. However, additional NGA standard or premium licenses are required for this setup, and NGA backend connections. The NGA basic package, which is part of the WinCC OA basis license, is limited to 6 event groups and 1 alarm group. The DRS, Disaster Recovery System, is currently limited to using the RDB option and NGA with PostgreSQL. Some functionalities are not yet supported, including split mode for redundancy is planned for version 3.21, and online backup is also planned for version 3.21. Dynamic blobs for InfluxDB and clustering for MS SQL. Here is some additional information about the NextGen Archiver. SQLite Configuration Database. Starting with version 3.19, WinCC OA additionally supports the use of SQLite as a configuration and last value database. This new SQLite database offers 0 voltage safety and year 2038 readiness, provides better performance and a smaller footprint. It is recommended for new projects with automated import available in version 3.20 and manual import possible since version 3.19. This ensures protected investments with long-term availability and constantly enhanced feature sets. However, there is one restriction to note: SQLite can only be used with NGA. Let's have a look at the architecture of NextGen Archiver. The architecture of the NextGen Archiver, NGA, in WinCC OA is designed to provide a flexible and efficient solution for archiving events and alarms. Here's a breakdown of its components and how they work together. NGA Front-End Manager. This is the main interface that interacts with users and manages the archiving process. It communicates with the backend to send and receive data. The process begins with the Front-End Manager, which is responsible for collecting data from various sources within the system. The Front-End Manager also handles communication with the backend processes, ensuring that data flows smoothly throughout the system. Backend. The backend is responsible for data storage and retrieval. In the NGA architecture, multiple backends can be used, such as InfluxDB, PostgreSQL, or MS SQL. Each backend handles the actual data storage and can operate independently. Data flow. The arrows in the figure indicate the flow of data between the front-end and the backend. The NGA Front-End Manager sends data to the backend for storage and retrieves data for user queries. The red arrows show how data is transferred from the Front-End Manager to the backends and databases. Redundancy. The architecture supports redundancy, meaning that there can be multiple instances of the backend to ensure data availability and reliability. If one backend fails, another can take over without data loss. Queue buffer. As data is collected by the NGA Front-End Manager, it is temporarily stored in the queue buffer. This component allows for efficient grouping of data points before they are sent to the backend. The queue buffer can utilize both memory and disk buffering to ensure data integrity, especially during periods of high load or when the backend is temporarily unavailable. Initialization, init. The init phase initializes the data manager, loads configuration settings, and prepares the system to handle read requests for tags and alarms. This setup is essential for ensuring that all components are ready to operate effectively. Data manager. Once the data is buffered, the data manager takes over. It manages the connections to the configured databases and facilitates the storage and retrieval of data. The data manager constructs and executes queries against the databases, ensuring that data is written in an optimized manner and that historical data can be retrieved efficiently. Event manager. The event manager plays a crucial role in handling incoming events and alerts. It prioritizes the storage of current events over historical data imports, ensuring that real-time data is processed and archived without delay. The event manager works closely with the data manager to ensure that all relevant events are captured and stored appropriately. User interface. The user interface allows users to interact with the NGA, providing access to configuration settings, monitoring tools, and data retrieval options. Users can query historical data and manage archiving settings through this interface, which communicates with the front-end manager and data manager to display the necessary information. Direct Read Control Extension. The Direct Read Control extension allows users to access the underlying database directly for faster access to historical data, bypassing front-end back-end communication overhead. In summary, the NGA architecture is modular and designed for high performance and flexibility. It allows for efficient data management and retrieval while ensuring data integrity and availability. Each component, from the front-end manager to the data manager and the queue buffer, plays a critical role in the overall functionality of the archiving system. As we reach the end of our presentation, I'd like to share some extra information on the topic of archiving with Oracle. This will provide you with further insights and enhance your understanding of the subject. Archiving with Oracle, RDB, involves storing values and alarms in an Oracle database. This method allows for a clear allocation between a data point element and a table, enabling direct historical data retrieval from the RDB through other database applications, even without WinCC OA. Configurable reduction of RDB Manager database connections allows you to manage database connections efficiently. The system supports fast retrieval of RDB values. Available for Windows and Linux. Multiple WinCC OA systems can store their archived data in a shared, common RDB system, ensuring service continuity even when the database connection has been lost except for database queries. Projects can start even when the database connection is unavailable, thanks to a two-step data buffer concept. Oracle compression can be configured via a WinCC OA data object, allowing for customizable compression levels, intervals, and functions. Fully integrated into the WinCC OA mass configuration concept. Now let's take a look at the Oracle Real Application Cluster, RAC. Please note that the Oracle Real Application Cluster, RAC feature is no longer supported in WinCC OA version 3.18 and higher, due to changes in Oracle's policy with version 19c. The Oracle Standard Edition DB license no longer covers the RAC feature. You've got two options here. First, you can upgrade from Standard Edition to Enterprise Edition. Or second, you can convert your Oracle RAC database to a single instance database. Switch and failover functionality is still available with option 2. As WinCC OA buffers, no data loss occurs at switchovers. More information can be found directly on the Oracle website. Now, we have reached the end of our presentation about the next generation archiver. Thank you for your interest in WinCC OA and your attention. If you have any further questions or need additional information, please feel free to contact us via email at wincc_oa@siemens.com. For more details on WinCC OA, you can also visit our website at siemens.com/wincc-open-architecture.